Hello, grade 10s. Welcome to New Dynasty Academy. In this video, we will be looking at the trigonometric function, but only the first video here. We are going to be looking at the sine function, and the series of videos will be following after this one, where we will be looking at the cos function and the tan function. And now, before we dive into the sine function, grade 10s, I want us to understand exactly why are we being taught the trigonometric functions in schools. You know that your education doesn't end in high school. So when you go into university, some of you will be doing courses like engineering, some of you will continue with the physics, and some of you might be interested in astronomy. Some of you may be doing computer graphics, and some of you may do music. You see all those courses that I've just mentioned. We use trigonometric ratios like in music for you to understand the relationship between musical notes and also to analyze sound waves and harmonics that is being done in music, and in computer graphics where you can use this function to render realistic lighting and shadowing. And you can also use that in astronomy to calculate the positions of distances of the bodies in the universe. It's used mostly in the field of physics, where you can analyze the wave sounds, the lighting, the movement of particles. You can use the sine function for that particular purpose. Guys, that is what I can just tell you now about the use of the trigonometric functions, but there are enormous uses. There are so many uses of trigonometric functions in real world. So without wasting any time further, let us just look at how are we going to construct or draw our trigonometric function. The first one, which is sine function. So grade 10s, this is how we're going to approach this lesson. You are going to redraw this table that you see currently on your screen and write all those angles that you see. Then you take your calculator using the function that is highlighted in red there, that is y equals to sine theta. You are going to substitute all those angles one by one and get the values and write those values in the empty spaces there. So you can just pause the video and go on and substitute and get your sine values. Then once you have done that, grade 10s, this is how your table should be looking like. And now we have got the angles and we also have got the y values. So what we're going to do next is that we are going to, if you don't have this picture that you see, something like what you see on your screen now, you can just pause the video again and redraw this quickly, because we will be using this to draw our trigonometric graphs. So we are going to use the values that we filled in the table, that is the y values and the x values. As you can see that those are coordinated points. You take them as they are, then you point them in this given Cartesian plane, and from there you'll be having points which you can join together. Then grade 10s, after the points have been put on your Cartesian plane, this is how they should be looking like after we have joined them together, and they form this wave-like motion from 0 to 360 here, and that is our one complete cycle of your sine graph, and that is how it looks like. And I believe that you have seen something like this before. Let's look at some characteristics or properties of this sine graph. Grade 10s, you can see that the graph starts from 0. It continues increasing until it reaches this point here, which is correlating with 90 degrees, and this point, that is the maximum point that the graph goes up. And let me just write here, it is the maximum point, so I'm going to just write as max. And who can guess what is going to be the point down there at 270 there? The point down there, that is going to be, if that one is the maximum, this point, I think someone has get it correctly, that is going to be your minimum. And yeah, that's how you identify that. But 90 is not your maximum point. The maximum point, remember, this graph starts at 0, going up in your y-axis, it reaches the maximum at 1. So the maximum here is going to be equals to your 1. Here the maximum is going to be equals to 1, and the minimum you can just guess it, that is going to be equals to -1. Then grade 10s, let us look at the motion. The motion starts from 0 to 90 to 180. At 180, that is half the motion. Then it continues to 270, reaching the minimum, and back to 360. That is a full motion, which we call it a revolution. That is one complete cycle. So your sine graph completes the cycle from 0 to 360 degrees. And what do we call that? We call that the period. So that is the period of your sine graph. The period is equals to 360 degrees. So we use the word period because we know that these graphs are periodic in nature. That is, they repeat themselves after every 360 degrees. So that is why we start at 0 then to 360, but we know that this graph continues to other measures going forward. Then again, the other thing that we can look at as the characteristics, it is called the amplitude of the graph. I know that some of you know these things because some of you are studying physical sciences and you do these things in physical sciences. That is the amplitude of the graph. The amplitude is the distance from the equilibrium, which is where you see your angles there, until to the maximum point. So the equilibrium here is 0 until the maximum point. What is the distance here? That is 1. So amplitude of this graph is 1. So that is the there is a formula that we can use also to calculate the amplitude. You can just say your maximum value, subtract your minimum value, that is basically the distance, halfway, then divided by 2, and that's how you can calculate your amplitude. Furthermore, even though we are only looking at the standard graph here, the coefficient of sine here, as you can see, you don't see anything, but we know that there's a 1 there. So the coefficient of sine is 1 there, but that is what I will be explaining. We'll be looking at some parameters that are affecting our sine graph. And another thing that we can talk about here is the domain. We have been doing that in functions like hyperbola, parabola, and a straight line. So domain, remember grade 10s, we talk about x values when you talk about the domain. So when you look only at this graph, which x value satisfies the equation? The x value starts at 0, even though you don't see 0 there, but it starts at 0 until 360 degrees. So your domain is going to be 0 degrees to 360 degrees. That is your domain of the graph. You can also write it like we use theta there, so you're going to say theta less than or equals to 360 and greater or equals, I'm saying equals to because those values are also included, 0 degrees. And the other characteristic is the range. Your graph ranges from the minimum to the maximum, and you always start with the smaller value and you put the corner brackets because those values are included. That is from -1 to 1. That is the range of your graph. And again, let me just talk about this without writing. Grade 10s from 0 until 90 degrees. As I'm going upwards from 0 until 90 degrees, do you notice that this graph is actually increasing, and it reaches 90 degrees where it becomes 0, then it starts going down, which means it is decreasing. So the x values where the graph is increasing is from 0 until 90 degrees, and it starts decreasing from 90 degrees until to 270 there. Then it starts also increasing until 360. So basically this is how you can take out or understand the characteristics of your sine graph. Then furthermore, grade 10s, we are looking here at the graph, but there are some things that are added here. We've got A and Q that are added there. These are the parameters that I was talking about that are affecting the graph. So what does the value of A do to the graph? The value of A, ignoring the negative signs, it represents the vertical stretch of the graph as well as the amplitude of the graph. The change in A will basically change the amplitude, as it will either stretch the graph or it will compress the graph. Then if A is negative, and then there is a reflection in the x-axis. If your A here is negative, then your whole graph is reflected on the x-axis. So as you know that if you reflect the graph on the x-axis, the y values will change. Then Q, the value of Q represents the vertical shift of the graph of y equal to sine x. So when Q is positive, the graph will go upwards. That is when Q is positive, positive denoted by greater than 0, and when Q is negative, that is less than 0, your graph will go downwards. And we talked about the period, that the period of the sine graph is 360 degrees. Now furthermore, let us go and look at how does the value of A and Q affect the graph. In this next slide here, we can see that we've got two graphs, the one in black and the one in yellow here. Let us quickly look at what is happening here. And the one in black, it has got 2. Remember what we our equation that we looked at the previous slide, it was A sine x, or it was a theta, plus Q, and I said that the value of A stretches the graph. So you can see that your standard graph or your mother graph here is ranging from -1 to 1 here, because the amplitude is 1. But look at this one where the value of A is 2. It is stretching, it goes up until 2 and it goes down until -2. So you can see that it was your mother graph which is now stretched to 2 upwards and to 2 downwards, and that's basically your amplitude. So if you can be asked what is the amplitude of this graph, I'm going to denote it as the letter A. The amplitude is going to be equals to 2. And furthermore, grade 10s, looking at the next one here, let us look what change happened here. The change that happened is that we've got our 1 here. So that is the value of Q from our graph there. Then the Q is positive because it says +1. So what does that do to the graph? It shifts the graph by 1 unit upward. So you can see that the black graph was where it is now. It is where it is now, and now the yellow graph is the black graph shifted 1 unit upwards. I hope you do understand that. Then let us look at the next one. In the next one, we can see what really happened here. When you look at the formula down there, you can see that there's a -1. That is a -1. It might not be visible, but let me just show you that it's -1. So negative sign, that is a Q that is negative, it shows that your standard graph has been shifted by 1 unit upwards. So you can see that it is shifted from the black graph to the yellow graph by 1 unit upward. This is not really difficult for you to see, grade 10s. I can see that it is very, very, very easy. Then grade 10s, we are reaching to the end of this video. This is what you are going to do now. That is your work. You're going to sketch the graph of those functions, that is 1.1 and 1.2. Then you answer the questions. What changes do you observe as the value of A increases, and what changes do you observe as the value of A decreases? Then number 2, draw the graphs of the following functions and compare their maximum values, their minimum values, as well as the intercept with the axis with that of the mother graph. So you're going to compare this graph and the one of the mother graph, which I believe that you know how to draw, and you only use the interval 0 to 360. Grade 10s, please do that. And you can communicate with us depending on which platform are you watching us from now, whether in Facebook, Instagram, YouTube, or TikTok. Please interact with us. You can comment there. You can tell us if you have got a problem. If you were not able to draw these graphs, you can communicate with us. You can DM us and we will be there to respond to you. And thank you so much for watching this video to this end. Keep watching our videos. Please subscribe to our channel, like, comment, and share this video with friends. I'll see you in the next one.